Hello, this is Ellie Lochner of the Pacific Northwest National Laboratory. Today I'll be going over the GCAMdata user modification function capability provided in GCAM version 6.0. The user modification functions allow users to write their own function to modify a GCAMdata input or output without modifying the input CSVs or the GCAMdata R chunks directly. The modified object then gets plugged into the data system and passed on to all dependent chunks. And then new XMLs get created with user-specified suffixes to distinguish them from the core GCAMdata XMLs. And a reminder for this, you need to update your configuration file to include the custom XMLs before running GCAM so GCAM knows to run with those files. And the motivation behind this is to keep track of GCAM data changes from a user versus core GCAM assumptions, ensuring that user-implemented changes can be automated and are reproducible. Let's move to R and do a quick example of this. Let's say we want to adjust fertilizer share weights in just the US. The first question is, what GCAM data object has this information? We know that the file A322 subsector share weight in the energy folder has global fertilizer share weights. So if we put this in a DS trace call, we can track the dependencies, and we're going to look downstream from this input file. And if we expand this, we can see that the second object here has the description for the fertilizer sector. The subsector share weights from A322 subsector share weight are expanded into all GCAM regions. So this looks like it's probably the object that we need, but let's copy this and take a look at it to be sure. We can load this from the Drake cache and view it. And we can see that sure enough, we have all of our different regions and the share weights. So this is going to be the object that we'll modify in our function. Now we can write the function that modifies the fertilizer share weights. So the setup for this function is a lot like the setup for core GCAMdata R chunks. We're going to start by naming the function and then declaring the object that we want to modify. So we do that here, and this is the object from above. Next, we can declare any other GCAMdata inputs that we need but won't modify. And here we don't have any, so we're just going to leave this blank. Now when we move into the make, the first thing we do is we read in all of the data that we need using the getData function, and then we can read in any other custom inputs. And just a note on this, we don't want to include custom input files in the driver declare inputs, since we want to keep our custom files and our core GCAMdata files separate. For our example today, let's adjust share weights by reading in a custom CSV called FERT share weight additions 1, and then we'll bind the rows from this custom CSV to our original object. So let's take a look at what this file looks like. We go to our files into our mod inputs folder and open up this FERT share weight additions file. We can see that we're going to adjust share weights in just the USA in a few years. So let's go back to R. And after we read in this file, we're going to do the changes. So here's where we bind the rows from this new addition. And then the next step is to return the modified GCAMdata object. And here, just a note that the name of the returned object has to exactly match what we said we were going to modify in the driver declare modify. Now that we have our function written, let's run this. And the next step is to run driver Drake with the new function in our call under user modification. So here's where we specify that we're going to run the user mod FERT function. And we're also going to include a suffix that we will append to all affected XMLs. And this, again, is to just keep track of the differences between the core GCAMdata XMLs and our new user modified XMLs. So let's run this. Now that this is done running, let's look at our XMLs. If we go to our files and to our XML folder and scroll to the fertilizer XMLs, we can see that sure enough, we have our nFERT XML, which is one of our core GCAMdata XMLs, and then the nfert with the _1 suffix, which is our user modified XML. So this worked like we expected. Another thing we can do with this capability is to run it in a loop and create multiple user-modified XMLs using the same function. So for this example, let's say we wanted to update share weights for not only the US, but also for 2 other regions. So we'll keep the same method of binding rows from external CSVs, but before we can do this, we need to have a variable in our function that's going to get updated as we go through the loop. So instead of reading in the specific file here, let's read in an object called file name that gets updated as we go through the loop. So we're going to loop through all of the files in the mod inputs folder. So we'll copy this here and move it into this read CSV. Let's also take a look at the other CSVs that we're going to read in this loop. So if we go to our files and back to our mod inputs folder, we can see that these are pretty much the same as the initial file that we read in, except for different regions. So we'll read it in for Brazil, and then also for China, just as an example. So let's go back to R. The next step to do this is we need to clear the userMod_fert object from Drake's cache. And this is just because Drake doesn't recognize changes to the file name argument. So if you don't include this call, Drake may assume that all downstream objects and XMLs don't have to be updated. So we're going to want to always include that. And the next step after we read in our file is to run driver Drake once for each file. And we want to ensure that each run is associated with a different suffix. So again, we're using our for loop to append different suffixes to each of the XMLs. So let's run this, but first let's make sure our function is updated, and then we'll run our for loop. So now that this is finished running, we can see that we are getting updates for each of our new custom files that I showed before. So let's look and make sure our XMLs got updated. So if we go to our XML folder, we can scroll back down and see that sure enough, we have our core GCAMdata nfert file, and then the 3 user modified files that we expected. We hope this new method for integrating user code into GCAMdata is useful. And if you have questions or want to look at another example, there is a vignette in the R vignette folder. And this just goes into a little more detail on how this works and gives another example. And for other questions or comments, please use the GCAM GitHub discussions page. Thank you so much.